AI has completely changed software development. Today, a developer can describe a feature in natural language and get hundreds of lines of working code within seconds. It sounds like the future of software development. But there is an important question we don't talk about enough. Who will understand and maintain that code 6 months or 2 years later? And interestingly, this problem is not actually new. It existed long before AI. Imagine a company hires a consultant to build an important application. The consultant spends 2 years designing the architecture, implementing features, fixing bugs, and making technical decisions. Then the contract ends. A new developer joins the team. They now have to understand, why was the system designed this way? Why does this module depend on that module? Why is this workaround necessary? Why does changing one component break another? Sometimes the documentation is incomplete. Sometimes the original developer is the only person who really understands the system. So the new developer may decide, I don't understand this architecture. I'll rewrite this part. And suddenly, the company starts accumulating technical debt. Now introduce AI. A developer can ask an AI model, create a REST API, add authentication, implement this database layer, refactor this module, fix this bug. And AI can generate code extremely quickly. This provides enormous productivity gains. But there is a potential problem. The developer may understand what the code does without fully understanding why the code was written that way. And that distinction matters. Because software maintenance is rarely about writing the first version. The difficult part often comes later. Imagine developer A uses AI heavily to build a complex system. The code works, tests pass, the product is delivered. Then developer A leaves the company. Developer B joins 6 months later. Developer B looks at the code and thinks, why is this implemented like this? There may be abstractions that are unnecessary. There may be complicated error handling. There may be duplicated logic. There may be AI-generated patterns that the new developer isn't familiar with. So developer B has 2 choices. Option 1, understand and maintain the existing implementation. Option 2, ask another AI model to explain it, or simply rebuild the functionality in a way that makes more sense to them. And here is where something interesting happens. The company may have moved from consultant dependency to AI dependency. But we need to be fair. AI-generated code is not automatically difficult to maintain. A good developer using AI can produce excellent code. The real problem is how AI is used. If a developer blindly accepts AI-generated code without understanding it, the risk increases. But if the developer reviews the architecture, understands the implementation, writes tests, documents important decisions, and follows the team's coding standards, AI can actually improve maintainability. In other words, AI is a tool. The engineering discipline still matters. There are significant advantages. AI can dramatically reduce boilerplate development. It can generate unit tests. It can explain unfamiliar code. It can help developers understand legacy systems. It can suggest refactoring. It can generate documentation. And perhaps most importantly, it can allow a developer to experiment with an idea much faster. A task that previously took several hours might take minutes. That productivity gain is difficult to ignore. But there are risks. AI can generate code that works but is unnecessarily complicated. It can introduce inconsistent patterns across a codebase. It can make incorrect architectural assumptions. It can introduce security vulnerabilities. And perhaps the biggest risk is this: developers may stop learning the system they are building. If every difficult problem is immediately delegated to AI, developers may become good at producing code without becoming good at understanding systems. So, what should companies actually do? The answer shouldn't be, don't use AI. And it shouldn't be, let AI write everything. The better approach is human-led, AI-assisted development. The developer should remain responsible for architecture, The developer should review generated code. The team should maintain coding standards. Critical decisions should be documented. Tests should be mandatory. And AI-generated code should go through the same code review process as human-written code. There's an important lesson here. The real problem was never simply who wrote the code. The real question is, can someone else understand, test, modify, and maintain the code? A codebase written by a consultant can be difficult to maintain. A codebase written entirely by humans can be difficult to maintain. And a codebase written with AI can also be difficult to maintain. Good software engineering is about creating systems that survive the people who originally built them. AI can write the code. AI can explain the code. AI can even rewrite the code. But companies still need developers who understand the system. Because the future of software development may not be humans versus AI. It may be humans who understand software using AI to build it better and faster.